In this video we will see how we can convert a complex number from Cartesian to polar coordinates. A complex number z can be written as x plus iy, or the real part of z, plus I, the imaginary part of z. So this is the real part, this is the imaginary part, this is x, this is y, and here is the complex number in the complex plane, In order to turn the complex number from Cartesian to polar coordinates, we do the following. Here we need to find the modulus of the complex number. So we need to find the distance of the complex number from the origin. So it's x squared plus y squared, or the real part of z squared plus the imaginary part of z squared. And we denote it as r. And the angle here, theta. So using basic trigonometry, tangent of theta equals the opposite over the adjacent side, opposite side divided by the adjacent side. So it's y divided by x, or the imaginary part divided by the real part. Now using inverse functions, tangent function, we get that theta is arc tangent of im z over real z, or theta equals arc tangent of y divided by x. So the polar form is z equals r times e to the power of I theta, or you can write it r cos theta plus I r sine theta. So this is my polar form. I can visualize that. So I have polar coordinates, and here I have a circle. This is the radius r, and this is the angle theta. That's what it tells me, and z can be written also as like that in phasor mode, using phasor notation. Can be written like this. So let's see an example. Let's assume that we have the complex number z equals 2 plus 2i. The real part of z, the imaginary part of z. I have this complex number. So the first step is to find the modulus of this complex number. Is square root of 8, and using properties of the square root function, this is 2 times square root of 2. This is 2 times square root of 2. Now the angle theta should be arc tangent of the imaginary part of z divided by the real part of z. So the real part of z here is 2, and the imaginary part of z is 2. So it's arc tangent of 1, which means that theta is pi over 4 rads, or theta equals 45 degrees. So I can write it now in a polar form. I can draw a shape like that. So the radius is r 2 times square root of 2, and theta is pi over 4. So this is my graph here, r and theta. And finally I can write it that z equals r times e to the power of I theta. Z equals 2 times square root of 2 times e to the power of I pi over 4. This is the polar form.